In this video, we will learn how to exploit symmetry boundary conditions in EMS for SOLIDWORKS. Take a look at the model that is on the screen. Here I have two coils as highlighted. I also have a ferromagnetic core and then air geometry surrounding them. Imagine that I need to do a simulation where I am exciting both the coils and would like to understand the magnetic field around the coil. I would also like to understand the inductances, the resistances, etc. for the coil. Now this model inherently is axis symmetric, and hence to speed up the computation one can resort to solving only a portion of the model. So I've created a configuration where I have taken a quarter symmetry of this model, just a quarter of the main model. Let us see what are the steps involved in doing a EM simulation with quarter of the model. The first thing when you create a study is really the study properties. Now here in the symmetry factor, you need to mention the kind of symmetry or the kind of model that you're trying to solve. In this case, we are only trying to solve a quarter of the original model. Hence, we apply a symmetry factor of 0.25. Next, we also need to tell the program about some special boundary conditions at the plane of the symmetry. For example, these two faces. Now, we accomplished that by creating a tangential flux boundary condition. Now, as you notice here, we create a tangential flux boundary condition and we select all the faces that are there at the plane of symmetry. The faces need to be from the air geometry, from the ferromagnetic core, as well as from the coil. So by applying a tangential flux boundary condition, we tell the program that the flux on these two faces or planes are completely tangential. And last but not the least, while we are defining the coil, here we specify the faces that constitute the coil, the inlet as well as the outlet port through which the current goes. In the general properties, you notice that automatically the fraction of the coil, in this case only 25%, is brought in from the study properties. The number of conductors across the cross section does not change because still you would see 50 conductors across the cross section. Okay. And also the value, the RMS value of the current going through the coil does not change. Okay. So actually to create a model, these are some of the necessary steps that one need to go through while doing just a quarter or a portion of the model. Next, we will run this problem and take a look at the results, and I will show you how to interpret the results in the result table. So to run, I right click on the study and select run. Once the solution is completed, we will take a look at the results. Now we can take a look at the results. As far as the flux results are concerned, let's take a look at the magnetic flux density. The magnetic flux density results that you see here, they don't vary whether it's a quarter model or a complete model. So the flux values don't need to be adjusted or scaled. Next we go into the result table. Now several results in the result table need to be understood. For example, since we are only solving a quarter of the model, we would expect the results to reflect the quarter model. But in EMS, we actually scale back a lot of these results. For example, the inductance of the coil, both the self and the mutual inductance, is calculated as though the entire coil is there. So you don't have to do anything to scale down your inductance. The same applies to resistance. The resistance of the coil is also completely calculated as though the entire coil is there. So the inductance, the resistance, and the impedance are calculated as though the entire coil is there. So the only result that will be scaled is the force. So if you request the program to compute the force acting on the ferromagnetic part due to these two coils, the value of the force that will be computed by the EMS program will be just 1/4 of the entire force acting on the ferromagnetic part. So that's the only thing that you need to scale back. Everything else, the inductance, the resistance, the impedance, will be calculated and scaled by EMS as though we are solving the entire model.